Who jumps out of perfectly good airplanes in the name of science? Mr. C.
Well, happy Thursday to you. It is an exciting day for a number of reasons. Number one, today is the day that Perseverance, the spacecraft Perseverance, is either going to soft land on the surface of Mars or crash land. And we won't know after it does either one for 7 minutes. So today's the day, and it's supposed to come in our time at 1:55 p.m., right around there, 1:55 p.m. So I will get back to that in a little bit, and all things Mars. So second reason, it is an exciting day. I have postponed your Friday test. Woohoo! Until Tuesday of next week. Now, I want to tell you a number of reasons why. Number one, here are the reasons. It's a short week. It's one of the reasons. We didn't have school on Monday, President's Day. Number two, there's more information I wanted to cover. Number three, I wanted to focus on Mars. And number four, I wanted to focus on Mars because I knew this week was the week, and particularly today, February 18th, that the spacecraft Perseverance was going to make its approach, entry, descent, and hopefully landing. One way or the other, it's going to be a landing. So is it going to be a soft landing or a crash landing? That is the question. And I just heard today 50% of the space missions to Mars have not made it successfully. 50%. Now the last one that was similar to this one was successful in 2012. Curiosity, which is still operating, rover that's still operating on the surface of Mars. So anyway, I wanted to focus on Mars this week. I'll review some on Friday, and we'll talk about the Mars mission and its success on Friday, and then on Monday we'll review, and Tuesday our test of next week. Another, maybe an additional reason that this is so important week and focusing on Perseverance. You don't get that many opportunities to kind of up close and personal pay attention to space missions. I remember when I was in junior high and maybe a sophomore in high school, there were several space missions. At the time it was the Gemini space project that was practice for going to the moon. So it was a big deal, and I talked my mom into letting me stay home from school to watch the launches and the missions. So I was really into it. No wonder I teach middle school science, right? So anyway, I was all fired up about that kind of thing then. I'm all fired up about it now. And that was 1962, 3, right through there. Okay? That's a few years ago, I'd say. Yeah, that's a bunch of years. Yeah? So 62, that would be 38, 48, 58 years ago. So, wow. But I'm still fired up today. Still quite interested about all of that today. And then, just to kind of top it all off, as far as space missions I got to watch as they happened, nothing probably tops our first manned lunar landing on the moon, and moonwalk on the moon. Neil Armstrong, huh? So anyway, I watched that live, and it was exciting. You know, that's one small step for man, one giant leap for mankind. His quote, Neil Armstrong's quote. So anyway, it's a big deal. So I am really into it. Okay, so no tests until Tuesday, and we'll review. Now, I'm fired up about Orion, the constellation Orion. And I want to say a few more things about Orion today. And there'll be some questions about Orion on Tuesday's test. I'm going to tell you the kinds of things I'm going to ask today, a little bit more information. And I have good news for you. Over the next few nights, it's supposed to be clear. So go out and have a look at Orion, and especially Sirius. Last night I went out and I had a look, and it turned out the clouds cleared away, and Sirius was doing its twinkling thing big time. So I didn't see much color, but I could really see it twinkling because of the atmosphere, moving around a lot. So I want to make a few points too and tell you a few things I'm going to ask on Tuesday. I mentioned a light year. A light year is the distance that light rays travel in 1 year. Now they're traveling about 200,000 miles an hour. Light travels about 200,000 miles, I said it wrong, a second. I mean, it really hauls. So, really fast. Now, that means in 1 year, light will travel 6 trillion miles. And that's a light year. The distance light travels in 1 year is a light year. And the distance is 6 trillion miles. I've got it at the top so you can see it. A light year is 6 trillion miles. Now the closest star to the Earth is Alpha Proxima. It's 4 light years away. So that means when we see light from Alpha Proxima, it left 4 years ago, and it traveled 6 trillion times 4, 24 trillion miles away. Now I told you yesterday about Sirius. Sirius is about 9 light years away. That means tonight, if you go out and see Sirius, the light waves that are striking your retina left 9 years ago in 2012 and have traveled 9 times 6 trillion, or 54 trillion miles. That's Sirius. Let's see. Betelgeuse, the reddish star on the left. It's a red supergiant, remember, way bigger, 700 times bigger than the sun. And light left Betelgeuse 643 years ago, or 643 times 6 trillion miles. So it would be about 742. It's like 4,200 trillion, I think. So I think that's right. And that light left Betelgeuse in 1378. And it's taken that long to get to us. 643 years. That's during the Renaissance. And then for Rigel, light left there 864 years ago, so it's 864 light years away. 864 times 6 trillion miles, and it left in 1157, about the time the Crusades to free Jerusalem from the Muslims was occurring. Unbelievable. So all of that in the constellation Orion. Remember, the Lord made all the stars. His purpose was to reveal himself to us. So to reveal his greatness or his glory. And remember, he spoke 10 to the 22nd stars into existence, a 1 with 22 zeros behind it, stars, instantaneously. Wow. He deserves our praise and our worship, does he not? So anyway, have a look at Orion, maybe this weekend. So it is gorgeous. So there's all of that. the test, just really quick, I'm going to show you what else it will cover on Tuesday. So just in case you wanted to review this weekend, King Henry, so it'll cover that. So it's also going to cover a few of the key questions about them. The metric system, I'll tell you more about that tomorrow. It's going to cover atoms and what they're made of. Atoms are made of protons and neutrons in the nucleus, electrons orbiting, opposite charges, electrons negative, protons positive, opposites attract. Why do the protons hold together? Because of the strong nuclear force. Those two forces hold atoms together. It's the way Jesus created atoms, to hold together. So I'm going to ask you questions about that. I'll visit that again. I'll go over that again. And then I'm going to ask you about elements on here, the two sun elements, hydrogen and helium. It's hydrogen that's fusing. Hydrogen fusion. Helium is made. Heat is made. Light is made. So I'm going to ask you about all of that. That process on the sun, God's way to provide heat and light for us. Hydrogen, I'm going to ask you symbols. Hydrogen symbol H, helium's He, He, helium. I'm going to ask you about the two main gases in our atmosphere, O2 for oxygen, N for nitrogen. Most of our atmosphere is nitrogen. We don't want it to be mostly oxygen, or we get explosions on a regular basis. Not good. I'm going to ask you about that one, C for carbon, found in living tissues, animals and humans. And then I'm going to ask you for the metal Fe. What is Fe? Iron. And it's what makes our soil in Arizona and Australia reddish orange, and on Mars, reddish orange. Iron in the soil. Iron combining with oxygen and water, making iron oxide. So I'll ask about that. So just reminding you about that. So anyway, did I cover all of that? Yep. So I'm going to ask you, as far as Orion, these questions about Orion. I already said what a light year is. Who made Orion? Obviously God, because he made all the stars. Sirius is the brightest star because it's one of the closest, biggest ones to us. So it's why it's so bright. It is the rainbow star. I'll ask you to explain why. Why is it the rainbow star? Because it flashes in different colors of the spectrum, or rainbow colors, different colors of the spectrum. Roy G. Biv. So why do they twinkle? Because the atmosphere bounces light around. So I'll ask about that. Okay, it's 13 minutes in. I'm going to do a little stop and then come back and spend the rest of the time on Mars, and then show you 6 more minutes of the Mars video. So Mr. Phillip is going to take a short break with you, answer any questions you might have, and then back to me. And I am back. So, and I'm going to ask you these things about Mars. I'm going to ask you, first of all, where did it come from? God made it. So God made Mars. Okay? I'm going to ask you about its size. It's about half the size of Earth. I'm going to ask you what it's like. It's dry. Why? There's no precip falling on it. No moisture. So a little bit in frozen form. You know, it has ice caps. It's dusty because of winds. It has dust storms, sometimes that cover it. It's incredibly cold. The average temperature is like Antarctica, -80. That's the average temperature. It has a big temperature swing because there's hardly any atmosphere. So it can go from 70 degrees in the daytime down to -100 at night. That's why it cools off so much. because it's a long way away from the heater, the sun, and it doesn't have an atmosphere to trap heat at all like we do. I'm going to ask you what its thin atmosphere is made of. Carbon dioxide, CO2. Carbon dioxide. Carbon, C. Di is 2, so O2. CO2, carbon dioxide. Hooked together. So that's what it's made of. We think there was water on it at one time. I'm going to ask you why we think so. Here's why we think there was water on it at one time. The ice caps. So obvious. There are stream beds that look like they had water flowing over it at one time, and looks like there were big lakes at one time. That's why we're landing Perseverance in Jezero Crater. We think it was one time a lake, a water lake. So did God make it that way? Probably, but it could have changed after he made it. We don't know exactly. Okay? So another reason it's so cold is it's, like I said, a long way from the heater. So if you were on Mars looking at the sun would look half size because it's a lot further away from the sun. And then the gravity on Mars is about 38%. So if you weighed 100 pounds on the Earth, you'd weigh 38 pounds on Mars. Right about now, Perseverance is starting to be pulled harder by Mars's gravity. It's just really coming into being attracted by Mars. Now the reason I can say that is I'm taping this on Wednesday afternoon, late in the day. And Perseverance is about 22 hours out. So right now, Mars's gravity is starting to pull on it, kind of extra hard. So another thing about Mars, it has a massive volcano that's about 3 times taller than our Mount Everest. You 7th graders know this. So it's got a massive volcano, 3 times as tall as our Mount Everest, and it has a super deep canyon that's 10 times deeper than the Grand Canyon, 10 miles deep. So it's got a super tall volcano and a super deep canyon. Super deep canyon, super tall volcano. So if I ask you a couple of its supersized objects, you're going to say supersized volcano, supersized canyon. So anyway, I'll review those again. I'll come back over those again. When Perseverance hits the Martian thin atmosphere, one of the JPL scientists, the Jet Propulsion Laboratory scientists who helped design and build Perseverance, said the Martian atmosphere is enough to notice but not enough to help you. So it's not going to slow down Perseverance that much. Perseverance is going, when it hits the atmosphere, it'll be going about 12,000 miles an hour. There's just no way that it can land safely at that speed, so they've got to figure out how to slow it down. The thin carbon dioxide atmosphere of Mars will slow it down some, but it's got to get a lot of help. So it's going to be slowed down some. Then it's going to release a massive parachute. That'll slow it down. It's got retro rockets that'll fire in the opposite direction, action, reaction, that'll slow it down. So it's got those actually action toward Mars, reaction the other way, slowing it down. It's got to get down to about 2 miles per hour, where it's going to drop cables down and lower the Perseverance rover at about 2 miles an hour to the Martian surface, if all goes well. Temperatures as it goes through the atmosphere will hit 3,800 degrees Fahrenheit, almost 4,000 degrees Fahrenheit. So it's got to have that heat shield, which it's got to get rid of once it comes close to the surface. So the radar will work on it. So anyway, there's just a few things. Oh, one other thing. As it comes in, it only has a few mile wide corridor that it's got to hit. It's got to hit this very narrow corridor. It can't come in too steep. So actually it's a corridor width like that. If it comes in too steep, it'll burn up. If it comes in too shallow, it'll skip off the thin atmosphere and go back into space. None, those two things, neither of them are good. So, not good. So anyway, it's got to be just right. Today there was a news conference and they said right now it's lined up on that narrow few mile corridor that it's got to hit. That's good news. I hope it's there tomorrow. So when you'll be hearing this. So anyway, I hope I'm not confusing you with that. I don't think I am. All right. I've got about 3 minutes before you see the last 6 minutes of the video about perseverance. Hope you've enjoyed it. I really enjoyed that video. I was telling a friend about it today. Just saying, you've got to watch this. It's really interesting. Now remember, I love all this stuff. I'm very enthusiastic about it. I'm not faking. This is like really exciting. I feel like a kid inside. Just like when I was a freshman or sophomore and talked my mom into letting me watch the Gemini missions, launches, and then missions from home on TV. So anyway, it's a big deal. I've got a number of why questions I'm going to ask. Now, I'm going to go over these again tomorrow and Monday. So I'll try to go over them semi-slowly. I'd stick these in my journal if I were you, and then I'll give you answers on them eventually. You might be thinking about answers for these, and then I will go over them tomorrow and on Monday. Here are the why questions about Mars. Why is it orangish red? You already know. Why is Mars orangish red? I don't think it should be called the red planet. It's just my opinion. Mr. C, it's a shade of red. I would rather call it orangish red. To me it looks, rust is orange, it looks orangish red. So why is it orangish red? So number 2, you don't have to scramble to get all 7 of these questions right now. Number 2, why is it so cold? There are several reasons. Why is Mars so cold, averaging minus 80 below 0 Fahrenheit, like Antarctica? Number 3, why is there such a big temperature swing from day to night? I hinted at it already, more than hinted. I gave you the answer. Why is it orangish red? Why is it so cold, like Antarctica? Why is there such a big temperature swing? Could be as much as 70 in the daytime, but minus 100 at night. Why is there no precipitation? No rain, snow, hail, sleet. Why no precip on Mars? Number 5, why does it only have about 38% of Earth gravity? Why only 38% of Earth's gravity? What's the reason for that? Next, why is there a 7-minute delay in sending and receiving signals to Perseverance? Why? So after it soft lands or crash lands, we won't know for 7 minutes till we get signals back, or no signals if it's totally destroyed. And then why is it cratered? Why does it have lots of meteorite craters? What's the reason? Why is it orangish red? Why is it so cold? Why the big temperature swing? Why no precipitation? Why 38% of Earth's gravity? Why a 7-minute delay in sending and receiving signals to Perseverance as it comes in and lands? And then why is it so heavily cratered? Okay, so I'll give you answers to those. I'm going to turn it over to Mr. Phillip to show you the last 6 minutes. And it's going to be an exciting day today or tomorrow, because I'm taping this for tomorrow, today. So anyway, we'll know more by tomorrow at this time. So when I do Fridays. Okay, see you back on Happy Aloha Friday, and I hope it's a happy Aloha Friday for Perseverance.